You are inside it right now. Not metaphorically, not in any poetic sense. The sun's atmosphere, a continuous stream of plasma and magnetic field it exhales into space, extends past every planet in this solar system, past Jupiter, past Saturn, past Neptune, past Pluto, and 3 times further still. Voyager 1 launched in 1977. It traveled for 35 years before finally crossing the outer boundary of that atmosphere and entering interstellar space. You have lived your entire life inside the sun, and nobody told you. That is the first thing you need to understand about what we are actually dealing with. We learn early that the sun is 93 million miles away, a safe distance, a manageable number. We feel the warmth on our skin on a summer day, and we think we understand the arrangement. A star at a civilized remove, keeping us at exactly the right temperature. But there is no such thing as a safe distance from the sun. There is only the question of how deep inside it you are. The corona, the sun's outer atmosphere, reaches temperatures of up to 2 million degrees Fahrenheit, 200 times hotter than the surface directly below it. Think about that. Stand back from a fire, and you feel cooler, not hotter. Walk away from a furnace, and the temperature drops. The sun breaks that intuition completely. Its atmosphere is hotter than its surface, and as of this moment, we do not fully understand why. This has been called the coronal heating problem, and it has occupied astrophysicists for nearly 90 years. The solar wind is a continuous supersonic stream of charged particles, electrons and protons, stripped from atoms by the corona's extreme temperatures, accelerating outward into space at between 300 and 700 kilometers per second. More than 1 million miles per hour. It never stops. Night or day, calm or active, the sun is continuously exhaling, and everything in the solar system is bathed in that exhale. Earth's magnetic field intercepts it, deflects it around the planet, channels a fraction of it into the polar regions where it glows as the northern lights. Without that magnetic field, the solar wind would hit the atmosphere directly, stripping charged particles from the upper layers. We know what that looks like. Mars is the example. Mars once had a global magnetic field. Then, around 4 billion years ago, its interior cooled and that field collapsed. After that, the solar wind no longer had a significant barrier to push against. Over hundreds of millions of years, it slowly eroded the Martian atmosphere, stripping away molecules one by one, gradually thinning a sky that may once have been thick enough to hold liquid water on the surface. Today, the Martian atmosphere is less than 1% as dense as Earth's. The surface is a frozen, irradiated desert. Scientists believe solar wind erosion is a major part of the reason. Not the only reason. Mars's story is complex, but a central one. The sun reshaped an entire planet by simply continuing to breathe. But the solar wind is only the baseline, the ordinary condition. The sun also storms. When the sun's magnetic field lines tangle and rupture, and they do constantly, they release stored energy in events called coronal mass ejections. A single coronal mass ejection can expel billions of tons of magnetized plasma into space at up to 2 million miles per hour. These are not explosions on the sun's surface. They are explosions of the sun's atmosphere, hurling material across the solar system. When that material hits Earth's magnetic field, it drives what we call a geomagnetic storm. Most are moderate. The grid flickers. Satellites experience interference. GPS drifts by a few meters. In 1859, we had one that was not moderate. On September 1st of that year, an English amateur astronomer named Richard Carrington was sketching sunspots when the sky above his telescope went white. He was watching a solar flare erupt in real time, the first human to observe one and understand what he was seeing. The coronal mass ejection that followed traveled from the sun to Earth in 17 hours. Most take 2 to 3 days. The geomagnetic storm it triggered reached every corner of the planet. Telegraph operators across North America and Europe watched their equipment catch fire. Sparks leapt from wiring. Some telegraph lines transmitted messages with their power sources completely disconnected, running on current induced by the storm alone. In the Rocky Mountains, gold miners woke at 1 in the morning and began cooking breakfast, believing the sun had risen. The northern lights were visible as far south as the Caribbean. The entire communication infrastructure of 1859 failed simultaneously. And in 1859, that was survivable. Now think about what we have built since then. Power grids spanning entire continents, tens of thousands of satellites threading every orbit, GPS woven through aviation, shipping, medicine, and financial markets, undersea internet cables carrying the data backbone of the global economy, a civilization so dependent on electromagnetic infrastructure that hospitals, water treatment, transport logistics, and financial clearing systems all fail the moment large sections of that infrastructure go dark. A direct hit from a Carrington-class storm today could cause widespread blackouts and prolonged damage to electrical infrastructure. Transformers that take over a year to manufacture, cascading grid failures spreading across interconnected regions. The economic damage has been estimated at trillions of dollars. In July of 2012, a coronal mass ejection of Carrington intensity erupted from the Sun. It missed Earth by 9 days. 9 days. This is not a theoretical scenario. It is a documented near miss on a specific date, recorded by NASA instrumentation in real time. The Sun produced an event capable of resetting the electrical infrastructure of modern civilization, and Earth was not in the path. 9 days earlier in its orbit, it would have been. And yet we sent something toward the source. The Parker Solar Probe launched in August 2018. Its mission, stated plainly, was to fly into the Sun's atmosphere and survive long enough to take measurements. For 6 years, it used the gravity of Venus to slowly bend its orbit inward, 7 flybys, each one tightening the spiral, until on Christmas Eve, 2024, it made its closest pass. It flew to within 3.8 million miles of the solar surface. That sounds large until you scale it. If you compress the full Earth-Sun distance into the length of an American football field, Parker would be inside the 4-yard line, closer to the end zone than to the nearest yard marker. And it was moving at 430,000 miles per hour. Fast enough to travel from New York to Tokyo in under a minute, the fastest object ever built. The heat shield facing the Sun reached nearly 1,800 degrees Fahrenheit. Behind it, the instruments were held at room temperature, a 4.5-inch wall of carbon foam separating the mission from an environment that would have destroyed any unshielded structure within seconds. What Parker found inside the corona was not what models had predicted. The solar wind close to the Sun is turbulent in ways that existing frameworks hadn't accounted for. There are structures in the magnetic field called switchbacks, sudden sharp reversals in the field direction, like a wave cracking backward through the corona. And their origin is still being debated. Particles in certain regions are being accelerated to half the speed of light by processes we are still working to characterize. Every close orbit has returned data that required revisions to existing models. We have studied the Sun from 93 million miles away for centuries. Parker went inside it, and it found that the view from outside had not prepared us for what the inside actually looks like. In 5 billion years, the Sun will exhaust the hydrogen fuel in its core and begin to expand into a red giant. Over millions of years, it will grow outward, swallowing Mercury, then Venus. Whether Earth drifts far enough out to survive is not certain. But that end is so distant, it is almost abstract. The less abstract fact is this. Right now, at this moment, you are inside the outer atmosphere of the Sun. A stream of plasma from its corona is moving past this planet at over 1,000,000 miles per hour. The magnetic field the Sun generates extends to the boundary where our entire solar system ends. Its storms carry enough energy to darken continents. Its influence has stripped the atmosphere from at least one neighboring world. And the spacecraft we sent to study it from the inside came back with questions that didn't exist before it left. We have been looking at the Sun our entire lives. We have been looking at it from inside it, without knowing that's where we were standing. And the closer we get, the less we find we understood.